I'm going to talk about some of the things we're seeing at Red Hat around application development and platforms and runtimes, how things are evolving. And having sat through some of the NGINX presentations today, looks like we're seeing some of the same things. I work at Red Hat. I'll throw my biases out there right away. I'm originally a Java guy. I worked for Sun Microsystems for 10 years. I've been part of the whole kind of Java ecosystem for the last 2 decades. And I'm also on the board of the Node.js Foundation, so I'm pretty passionate about Node.js and JavaScript. So I certainly have some biases, and they may come out through this. But what Red Hat has to provide is developer tools, runtimes for everybody, for a large customer and partner ecosystem. And I'll talk about some of that. So I'm not going to show code. I'm not going to get super technical. We'll start off with this kind of idea of digital transformation. What I've learned today is that it's a pretty kind of forward-looking crowd here, so I don't think I need to spend too much time on that. Talk about how I'm a kind of technology historian. I always like looking back in the past and see where we've come, because often gives us clues about where we're headed. Talk about some evolution around architectures, how you deploy and build applications. And if we have time, I'll talk a little bit about serverless. Serverless is another kind of product group I run at Red Hat, so I'll kind of give you some perspective from Red Hat about serverless as well. But what I have is a kind of real mishmash of slides here from about 3 different conferences, so they may appear a little bit disjoint. And I'll definitely want to save some time at the end for questions. So look, just briefly, the way we talk about digital transformation is it's about leveraging innovation in technology. As a technologist, there's a huge amount happening in technology right now, and if you're able to embrace it, you can really differentiate your organization. But that technology alone isn't enough. I mean, to be able to compete and deliver faster and better applications ahead of the market, we've really got to rethink about how we deliver applications, build, design, deliver applications. And if you can get all of those things right, you can really transform your business and hopefully in your industry be the next Uber or Lyft. The way Red Hat talks about applications, may be kind of different from some of your perspective. We typically serve enterprise organizations building mission-critical applications, airline booking, banking systems, so large infrastructure projects. And they're really kind of, it's a 4-legged stool the way we think about modern applications. There's the traditional app dev stuff, how we build and architect custom applications, the space that app servers used to take over. How we integrate, so any app worth its salt has to integrate with something, talk to a backend, a database, some feed of some kind. So there's how we integrate. How we use data in large quantities of data in real time. So how we use that raw data to be able to train applications to make decisions themselves. And the more we look at this, the more we move into AI and machine learning as well. And then automation. We have a traditional kind of rules workflow engine as part of our portfolio. But again, the more we look at this, the more we see things moving towards machine learning, artificial intelligence. So I was a developer, 15 years ago for about a decade. I built large, complex distributed systems for airlines and space companies and whatever. And the way we build software today is very, very different from what I'm used to. Organizations, in order to compete and deliver applications rapidly and stay ahead of the competition, you really have to let go of this kind of waterfall process and move towards agile software development and ultimately automated delivery and DevOps. And that's really as much a cultural change and a state of mind change than just a pure process change. I think that's one of the hardest problems. Where we deploy is rapidly changing. So we've moved from in your own data center running on bare metal or virtualized instances to cloud hosted, containerized. And now we're kind of moving to, I think most organizations are settling around some kind of hybrid mode where they may have their own data center, but they may also offload onto some utility cloud out there somewhere. And then to support this kind of rapid software delivery, the architectures are changing. Going from monoliths to web to backends as a service, PaaS. Things are evolving very, very quickly. It's almost hard to keep up with. Microservices are still kind of pretty much the buzzword du jour. We've been talking about microservices 4 or 5 years. I would still say it's not really mainstream. And already people are thinking beyond microservices. So things are moving very, very quickly. But organizations really have to embrace these. You have to embrace the culture and process change around DevOps. You look at different infrastructure around automation, and also look at different building and architecting applications very, very differently to kind of compete and survive in a increasingly competitive world. But we caution people when we talk about this transformation, and I really hate build slides, so I'm just going to kind of race through this. Where everybody wants to get to is this kind of cloud native nirvana or microservices where they can do 2,000 changes per day with zero downtime. Decompose all your functionality into microservices. That's where we want to get to. But that's not where we're starting. Where we're starting is, classic software delivery, long life cycles. So we work with organizations through our consulting practices, and we have a labs organization to kind of help people make this transition. And what we tell people is you've got to do all of this stuff beforehand, right? You've got to follow the evolution. You can't just. There's no point in taking your existing monolithic applications and re-architecting them as microservices. The only thing that's guaranteed there is failure. You really do have to look at organization and culture around DevOps. You have to look at your software delivery capabilities. If you're unable to deliver software 50 times a day, there's no point in building microservices that allow it. Right? You have to have that delivery capability to be able to make use of the architecture. So we typically walk through people. There's a series of steps here, and you really shouldn't be moving on to that next step until you've mastered the previous one. But I won't belabor that too much. So I'm a Java guy, app server guy. I kind of grew up on app servers. I worked for Sun, a bunch of other companies. And this was for people building enterprise applications, big airline booking systems and banking systems. WebSphere, WebLogic, were the standard platforms. Java kind of defined that market. Microsoft had .NET, similar kind of thing, similar kind of architecture. And this application platform was really kind of composed of 2 big chunks. There was the bunch of APIs for developers. Java defined that, or the Spring framework defined that. So a bunch of APIs for developers to use that were backed by services for doing things like transactions and object to relational mapping, messaging, et cetera, and then a whole other chunk of infrastructure stuff for doing logging and distributed deployment, provisioning. So a whole bunch of operational capability as well. And we kind of bundled all that into a big monolithic, big heavyweight. And I always think of WebSphere Classic, right? Big heavy piece of heavy industrial middleware. Roll forward, and certainly for our perspective, we've made this shift. A couple of things have happened. One is, developers want choice. They don't just want to write in Java or Java EE or Spring. They want choice. They want to use Node.js. They want to use Ruby, Go. many other languages and frameworks. So we need to offer developers this kind of polyglot language environment so they can use the most appropriate language and framework and runtime according to the task. And then all of that operational stuff has now been delegated, in our case, to OpenShift. OpenShift is our container platform. It's basically built around Linux containers, aka Docker, and Kubernetes is the orchestration layer with a wonderful user experience built around it, and all built on Red Hat Linux. So we no longer need to build all of those operational capabilities into each piece of middleware, message buses and ESBs and app servers. We do that in a single way within OpenShift. And that's a really good advancement. It means you can, as a kind of operational footprint, you only have one thing to deal with. The way you manage workloads, they all kind of look the same operationally. So there's definitely some efficiencies there. And for us at least, OpenShift is highly portable. It runs anywhere where Red Hat Enterprise Linux runs, it runs. So it runs on Azure, Google, and Amazon. Runs in your own data center, runs on bare metal, runs on virtual appliances, wherever you want to run it. So this is kind of the at least the middleware of I'd say 2014, 2015. But to get to this kind of cloud native nirvana, we need to go a little bit further. Kubernetes doesn't do everything we need it to do. This is definitely a good architecture and a good direction, but it doesn't get us there. And we'll come back to some of the missing pieces. So again, just some kind of news from analysts. I'll kind of skip through this pretty quickly. The traditional app server world, in my case Java, but it's true for .NET as well, is definitely plateauing. Red Hat's the only kind of growing vendor because we're taking migrations from other vendors, but everybody else is kind of shrinking. So it's definitely a market that's plateaued because people are thinking about different architectures and looking at different technology stacks to run those new applications. Kind of very, very quickly, microservices. Martin Fowler defined it. I'll just kind of pick on a couple of key pieces. So independently deployable, independently scalable. They're super important. If you want to be able to deliver small incremental changes that don't have ripple effects through the whole system, you need that kind of independent deployability. Because we're now, microservices are distributed systems, we've added a bunch of complexity. We've traded off flexibility, deployment flexibility for a whole bunch of code complexity. In a monolithic applications running a single process, a function call can't really fail, unless you get a kind of stray proton knocking a bit over and corrupting your stack. Function calls really can't fail. Network calls really can fail for 1,000 billion different reasons. So you need to build in some resilience into the applications, which is a whole level of complexity, and we'll come back to that. I mentioned polyglot. Developers just demand choice. They demand to use the most appropriate technology, the most efficient technology to get their job done. Most developers just interested in getting the job done as quickly and as well as they can. Microservices are typically event-driven. The world is kind of moving to this kind of event-driven programming model, which is definitely goodness. And that's naturally kind of going to bring in API and contractor-driven services. And there's good and bad and the ugly. I mean, the good about microservices, good general kind of computer science 101. Domain-driven design, just like object-oriented programming, low coupling, high cohesion. These are all good things that we've been taught in computer science class for decades. It's all good. I think one of the best things is when we think about microservices, we have to rethink about how we deal with data. It turns out that putting all your data into a relational database may not be the best model for everything. I'm not a database person, but the joke in the database world is the most common schema is key, comma, value, right? We've tended to just shove everything in this database because it's kind of free and it's available. Turns out that's not a good design pattern because there's a whole bunch of conceptual and performance overhead with a database. So rethinking about how we deal with data is definitely a good thing. So the bad around microservices, definitely too much kind of computer science involved here. Most developers just need to get stuff done. They don't really care about the theory and the computer science. At the end of the day, you're just trading off between agility and flexibility and some additional code and operational complexity, having to deal with distributed systems. We certainly aren't pushing anybody to go to microservices. It's definitely a solution for some organizations, for some applications, but there's nothing inherently bad about monolithic applications or existing service-oriented architectures, as long as they're kind of delivering what they intended to. Way too many organizations get this kind of microservices envy, where this is the shiny new thing, and you've got to go build the next app using microservices or serverless or whatever comes next. That should definitely be avoided. And when we think about microservices, people typically look at Amazon and Netflix and these very well-funded Silicon Valley companies who can hire some very, very good people. Not every organization can necessarily hire those same skills and has those same capabilities. So you really got to look at the organization to know if you can really head down this path for all your applications or any of the applications. And then, the bad, how we deal with data in distributed systems. It's a tough problem. People have been writing PhD theses about this for decades. We'll come to that a bit. Definitely looking at how we deal with databases, more as streams of changes and events is definitely a kind of good direction. There's a good book here from one of my colleagues, which you can download for free if you can grab that URL. It's a huge subject, but I think to really kind of take on these new architectures, you really have to think about data differently. Otherwise, the database just becomes the big monolith that couples all your services together, both physically as an endpoint, but also kind of logically because of this shared schema. So you've really got to consider the data and understand how to deal with data differently. And then the ugly, I've built large distributed systems for decades, and it's really, really hard. There are lots of things you can do wrong. Some of the maturity around monitoring, visualization, management definitely need to catch up. How you kind of understand the application when it's composed of hundreds of different deployed pieces is going to be a challenge for the dependency tools. This idea of being able to deploy services using different languages sounds great, except in 5 years' time when you have to maintain this stuff and the language you decided to write these things in is no longer supported. So you've got to kind of, just because you can write in multiple languages doesn't mean you have to. Microservices are inherently asynchronous event-based. There's a whole kind of area of research around reactive programming, reactive systems that deals with this. It's fairly new. It's fairly niche. Getting skills around asynchronous event-driven is pretty challenging. So there's definitely some expensive skills here. But dealing with data is definitely the biggest challenge. Without kind of going into CAP theorem, you can't have. With data and transactions, you can't have your cake and eat it. You have to choose consistently available partition tolerance. You've got to choose 2 out of the 3. You can't have all 3. And this is a very fast-moving, even for professional technologists among us. I just almost find the wave of technologies coming across my browser and my email feeds just pretty overwhelming. You think you've caught up, and then there's a whole other area you need to look at. So the state of the art is definitely changing. Hopefully there'll be some stability at some point, but it's still moving fairly rapidly. And we're definitely, I would say, at the kind of just past the peak of inflated expectations. I'd say that was probably 2015, 2016, kind of sliding down the trough of disillusionment. I get out and speak to customers worldwide, on a weekly basis, and I talk to a broad range of customers, very, very early adopters of microservices who took this on 2 years ago, They're all already learning from their mistakes. They're building version 2 and version 3 of those microservice applications, building on some of the challenges they made. I also speak to customers who kind of skipped past SOA, skipped past web architectures, and are now thinking, how do you go from mainframe to serverless, right? They're looking at skipping whole generations of technology as a way to try and keep up. So because they look at microservices and think, yeah, this is kind of hard. There's a lot of rocket science involved here. So again, I'm a Java guy, so I'll talk from my perspective, which is around Java. So around 2014, if you were building microservices, you were likely using this kind of stack. Deploying a Cloud Foundry or OpenShift or directly to Amazon, and you would really have to construct your own stack using things like Zipkin and for tracing, and a config server, Ribbon for doing load balancing, Hystrix. You'd really have to kind of build your own application to really be able to implement some of the design patterns in so some of the kind of books that were coming out at the time. Some of these libraries implemented design patterns, so you didn't have to go and build them yourself. So you have to build your own stack and essentially build your own kind of server infrastructure just to be able to run a single microservice. So that's quite complicated. The date's wrong on this. I would say like 2016, with kind of next generation platform as a service built around Docker and Kubernetes like OpenShift. A lot of those things we could get rid of because they have built-in config servers. They would do your proxy and load balancing for services, would have visualization and management monitoring and metrics. So, the stack became more simplified if you're deploying to something like OpenShift, but still pretty complex, still lots of moving parts. And the worst piece was that a lot of these technologies are just libraries, and what they require you to do is include annotations or code into your application logic to be able to implement some of these design patterns. So it was a real kind of anti-pattern in early microservices where you had typical business logic munged in with deep, complex infrastructure code, and that's rarely a good combination from a maintenance point of view. So I'll introduce some other terms. Some of this was already spoken about before. I'm going to talk about service meshes and specifically Istio, and I'll kind of introduce this idea of a sidecar. A sidecar is basically a process that runs next to your service that acts as a proxy. And it's really that simple. It's an incredibly simple design pattern, but it's incredibly powerful. It means you can do policy enforcement, you can do management monitoring, you can do message transformations, all kinds of stuff within that proxy without having to push that code into your application code, so you can keep your application service nice and neat. So it's a super powerful idea. And one of the very popular ones is Envoy. So we can run in Kubernetes or just a container. So for every service, we have this sidecar, and the sidecar becomes the kind of public face of that service. So it also allows me to do client-side load balancing, server-side load balancing. Allows me to do proxying, redirection, failover detection, all kinds of neat stuff with a very, very simple pattern. And that's mostly what Istio is. Istio is a project kicked off by Google, IBM, Red Hat joined, Nginx joined, a whole bunch of other companies joined, Pivotal joined as well. So it's becoming kind of the standard service mesh implementation. And really it is this sidecar and a bunch of additional technologies, which I'll get into. And really what it allows you to do is from a very, very high level, is push all of that all those infrastructure concerns down to the level they should be in. So out of your application code, and into the infrastructure. And once they're in the infrastructure, we can make it policy-driven versus code-driven. So as a software designer, engineer, this is goodness. It also means we can do some cool stuff. The things you can do inside a JVM or a Python process are pretty limited versus what you can do on the outside with networking, so having virtual networking. So we can do some clever things that we can't do inside the JVM or inside your virtual machine. It also means we only have to do this once. This is all language independent. I don't need some kind of complex retry mechanism for every single language and runtime. I don't need to implement client-side load balancing for every single language and runtime. I can do it once in this service layer, this service fabric, for all languages and all runtimes. And that's much cleaner, much easier to manage, and presents way less kind of technical debt. So typically service meshes. Istio isn't the only one, but it's by far the most popular. It's runtime and framework independent. It implements these sophisticated design patterns within the service mesh, so your applications don't need to, whether it's circuit breakers, distributed tracing, auth and access control, telemetry and logging, are all taken care of at the layer below. So this is basically what Istio consists of. As I said, it's this Envoy sidecar, something called Istio Pilot for doing proxying traffic management, routing, and the shape of the service mesh, authentication, access control with the Istio Auth, and then Mixer for doing kind of host of things like metrics, monitoring, reporting. So all of those together are basically Istio. The plans for Istio, so it's was started by Google, IBM, big contributor, Pivotal, Red Hat, Nginx, is it's unclear whether this will become part of Kubernetes or will be a layer on top of Kubernetes, and we don't really care too much. But to us, it's an essential piece of the stack to really make this kind of cloud-native architecture come through, because it means we can get rid of all of these additional application-level libraries. There is no need to use these things anymore with this kind of service mesh architecture. Again, we can go move all this down to a different layer out of our code into a kind of policy-driven layer, just like Kubernetes, and that's definitely good for developer productivity and long-term maintenance. So in our case, our platform looks something like this. We'll support a whole bunch of modern runtimes for developing cloud-native services, Vertex for doing reactive Java applications, Node.js for doing server-side JavaScript, Wildfly Swarm for more of the kind of Java-y centric applications, Spring Boot, all running on OpenShift, with Kubernetes and Istio, and running on any cloud, all clouds at the same time, or even in your own data center. So very high level view. That's kind of our future architecture. So we give developers choice. We remove a whole bunch of complexity around building cloud-native applications and microservices, but also give you kind of flexibility of where you want to deploy it. So this idea of polyglot from a language perspective, poly-architecture, whether it's stateful applications, monolithic applications, microservices, they all run fine in OpenShift. And multi-cloud, so run in any cloud provider or your own infrastructure. But we can't stop there. There's an evolution here. We had microservices. We had service-oriented architectures. Have kind of evolved in some degree to microservices. The latest is function as a service, where we take the amount of code we can deploy and execute down to the smallest possible piece. So single actions versus single purpose services. So Popular examples are Amazon Lambda, Apache OpenWhisk, Google Functions are all implementations of this function as a service or serverless architecture. And I think for many tasks, this is where people are going to end up. From a developer perspective, microservices are pretty complicated. They offer a whole bunch of new capabilities and advantages, but there's definitely some inherent complexity there. Function as a service has really kind of stripped away a lot of that complexity. You don't really need to care about building and packaging and deploying applications. You just got to care about the code and let the machinery figure out how to execute it at scale. So it's pretty elegantly simple for some kinds of applications. So just kind of briefly, it's this kind of code execution model where it's super simple. You get an event, and there's an action associated with that event, and there's a result. And you're typically charged by the time it takes to execute the action. An example might be we see a file change on a storage volume, and we run an action to go load that file, transform it, and send it somewhere. So it could be, transforming a mobile picture upload, for example. And it's really that simple. So completely ephemeral, very, very fast running, and you can kind of execute this stuff at a massive scale. And it's really kind of an evolution of, we had the kind of traditional kind of web architecture with load balancers, web servers, app servers. Then we had this thing called mobile backend of the service and backend of a service, where your mobile application, the client code, would now take a big chunk of the actual code, and would usually through an API gateway would go call on services or access data stores remotely. So different architecture, and this is kind of really just taking it one step further. So the early examples of serverless are around single-page web apps, webhooks, or mobile applications, where my client-side application just had the need to do something like transform an image, resize an image, something like that. So serverless is all about focusing purely on the code, not on the what version of the virtual machine, JVM, or language runtime, or framework, which version of the operating system. I don't need to care about any of that stuff. I just write my application in my choice of programming language. Most implementations are polyglot. Node.js tends to be the favorite, but Python, Java, all the usual kind of suspects are typically supported. They're completely ephemeral. You have no state between calls. One call is just a new call. You can assume nothing happened in the future. So completely stateless, and completely very, very loosely coupled, completely task focused. And the utility billing for cloud providers is usage based. So you typically get the first 1 million invocations for free, and beyond that it's a couple of cents per million invocations. So very, very cost effective. There are good use cases. Covered some of these. Anything that can happen very, very quickly is a good use case for serverless, because of the charging model, because of the way the implementations are designed to scale and handle requests. On the flip side, anything that takes a long time, doing fast Fourier transformations or Monte Carlo simulations, probably not a good idea. Anything that blocks, anything that has to wait for I/O is not going to be a good option for serverless, I suspect. And as always, there are good things and there are bad things. Good things, you can scale this extremely well. Managing updates becomes very, very easy if you can get down to the granularity of a single function, especially an ephemeral function. It's very, very efficient from a pricing point of view. It's a great way to separate the infrastructure from the application. You really have no choice. You are not given any any chance of writing infrastructure code in your serverless function. I'd also say there's a good security advantage here. Given the time it would take to execute a serverless function, there's really not a big opportunity to do anything malicious. So that's good. And as always, there are bad things. It's definitely different. It's a different programming model. Takes some time to get used to. If you want to load your favorite object relational mapping library that is, 50 megabytes, probably not a good model for serverless. It's really not what it was designed for. There's a large variance in latency. Some of the implementations are incredibly sophisticated to do pre-warming of runtimes and functions. But if you're hitting something cold, you could have to cause the whole stack to be loaded from scratch and your function to be compiled or whatever, or optimized. Any kind of just-in-time optimizations not really going to make any sense, given that you only execute these things once. So some of the usual kind of optimization tricks are going to be useless in this environment. And definitely look at some of the pricing plans for the cloud service providers, because while they look attractive, a million invocations for $0 and 5 cents for a million after that, it looks attractive, but they will hit you with other resource limits for memory and CPU. So the pricing can be complex. And then the ugly, right now there's definitely a little bit of it does provide a little bit of a control point for service providers. If you're using Amazon Lambda, you're likely tied into event sources on Amazon, and it would be very, very hard to move somewhere else. There aren't debuggers for running serverless, quite frankly. So you've got to think about different ways of developing debugging and your tuning software. And it's very, very new. I've met with maybe 20 customers that are using serverless in production systems, and even then, they're not doing kind of mission critical stuff. So it's still fairly new. Getting advice and getting developers is going to be problematic. Just kind of zooming ahead to kind of cut the chase. We've been playing at Red Hat, playing with serverless in our labs and R&D for a couple of years now. We've looked at lots of different implementations, and recently we decided to go with Apache OpenWhisk for a couple of reasons. One is it runs on Kubernetes. That was a key requirement. Two, it's polyglot, supports any language, and has lots of bindings for different runtimes. And the most important is it's open source. We can only really look at open source technologies. So we're part of the Apache OpenWhisk project, and we're working with IBM and Adobe and a few others, and we'll have a tech preview up on OpenShift real soon. So what that means is, one of the limitations of serverless right now is you really have to look at the public cloud providers. If you're okay running in the public cloud, that's great. But if you want to run stuff in your own data center and get those efficiencies, then you're going to have a kind of local option as well. So that'll be, OpenShift running in your own data center with Apache OpenWhisk. So that was kind of whiz through a whole bunch of different subjects. Again, apologize for the slides, lots of different sources, but we do have a couple of minutes for questions or comments. You'll have to shout because I can't really see anybody with these lights. Any questions? Any comments? Is anybody using? Let me do a quick poll. Who's doing microservices? Would you say? Who's developing microservices in Anger? So still pretty new. Serverless. Anybody using serverless in Anger? Yeah, it's coming. The developers will start using it, and you'll have to care about it. Alrighty. Well, again, thanks for your time. That's pretty much it. And enjoy the rest of the afternoon.